Hi guys, this is Mr. Urrego, and today we're going to talk about scatter plots and lines of best fit. So first of all, you do scatter plots. It's an easy concept. What's the idea? I'm going to have some kind of table of x and y, right? X and y values. Or for the most part, we're going to have a lot of real world problems. But the idea is that we're going to have ordered pairs. And what do we do with those ordered pairs? We plot them. Okay? So positive correlation is when I plot my points, you see what's happening? That's the tendency of my points. That's a positive correlation. I have a bunch of points, and in this case, the black line that I just drew, that will be the line of best fit. It will go through most of my points, through the middle, and it's going up from left to right. When you think about correlation, think about the slope. Right? The slope of a line will be positive. It goes up from left to right. This is a positive correlation. Same idea with negative correlation. I'm going to have a bunch of points. I don't know how many points I'll have. I can have, all of them scattered, right? But for the most part, look at this. That's the way my line, my values are going, right? So from left to right, this is going down. Therefore, this is a negative correlation. Okay, think about the slope again. No correlation. No correlation happens when I have points all over the place. What's the idea? How can I draw a line? And if it's going up, is it going down? They're scattered, they're all over the place. There's no correlation. All right, that's it. Basically, that's it. So let me show you that. I'm going to use Desmos for this. So let me give, as my x values increases, let me go back, as my x values increases, my y values also increase. All right, so let me say that I have 1, 2, say 3, 3 again, 4, 5, 6. You see the idea? You see the idea, right? It's going up. It's going up. So this is 7. Okay, so that's a positive correlation. They're going up. The same idea goes with the other one. Negative correlation. So I'm going down as my x increases, my y's are decreasing. Okay, so that's the idea. You see that? My line, all my values are decreasing, so that's a negative correlation. And like I said, no correlation is they're all over the place. Okay, all right. So let's get into a common or a typical problem. Okay, so here we go. For the most part, they're going to be word problems. They're going to give you either a word problem, okay, or they're going to give you a table of values where you have to draw a scatter plot, find the equation of the line of best fit. Well, in this case, they're doing baby steps. They want you to compare. Find the equation of the line containing the first and the last data point, first and last point, and then you have to graph the line, obviously, and then graph a graphing utility, TI-83, TI-84, any graphing calculator, or in this case, we're going to use, in this case, we're going to use Desmos to draw the line of best fit. To find it, we're going to have a coefficient, R. Okay, that's a correlation coefficient. We're talking about in a minute. And the last but not least, we're going to have the line of best fit through my scatter plot. Okay, so let's do the first. So what I'm going to do first is I'm going to skip some steps. I'm going to get this information and I'm going to go straight to Desmos. So I'll show you how to draw the how to plot the points, obviously, and how to get the line of best fit. So let's get to Desmos. So the first thing that I need to do is hit the plus, get a table, and input all the values. I'm going to put 4, 5, 6, 7, 8, 9, and 10. And for my y values, I'm going to have 2, 4, 5, 2, 4, 5, 8, 10, 12, and 14. So if you notice, it's a positive correlation problem. Okay, very nice. Now, the idea is to draw, we have the scatter plot. This is called the scatter plot. Okay, if I want to zoom in, zoom out, move around, I can do it. Another way of doing it is I hit the range, there we go, and I can control what are the x values that I want to see. So because my values are from 4 to 10, I'm going to come to the x, and I'm going to erase all that. I'm going to put a 0. You got to erase 0 to, let's say, to 11. So let me hit that again, so I can see what values I control. Oh, I want to see a negative, so let's go here, -1. Okay, so I can see what values I want to see. All right, again, it goes from 4 to 10, so the best thing to do is probably what, 3 maybe. All right, so you can see the values. I can do the same thing for the y's. All right, here we go. So I have my scatter plot right there. Now let's find the line of best fit. So if you notice, here we go, there's nothing. Underneath you see a little 2 right there, I hit it. And I'm going to write my equation in slope-intercept form. So y equals mx plus b. Okay, before I proceed, my table is x1, y1. So in order for me to Desmos identify these table values, I have to write y1 and x1. But now Desmos erase everything, okay? Because a scatter plot is an exclamation. So let me erase the equal sign, all right? Scatter plot is an approximation. It's always called the line of best fit, all right? This is depending on the software or depending on what points that I use, and I'll show that in a minute. So I'm gonna hit this keyboard, and instead of the equal sign, I'm gonna write ABC, and I'll see the approximate equal to. Here we go. And now I have that. Let me close this again. Once I do that, now Desmos gives me everything. Beautiful. So I have my equation, y equals mx plus b. The m is the slope, 2.03751. The b is the y-intercept, -6 points. So let me write that down, because for the most part, that's the question they will ask you. Okay, so they will ask you, write the equation of a line of best fit. So I can write equal. I'd rather not. I'd rather have y approximate equal to, right? A little curve like that. Oh my God, I don't know how to do it. There we go. Some kind of curves like this. Approximate equal to. My slope is 2.3. I'm going to give 4 decimal places, 57 of x minus 6.39 and 2829. I'm rounding. And that's the line of best fit. This is the equation of the line of best fit. I want to write y approximately equal to. Okay? And that's it. What other information I get from here? I see the r. What's the r? The r is called the correlation coefficient. And if this r is close to 1 or -1, it means that the linear model, the line of best fit, okay, strongly reflects the relationship between my variables, between the values of the x and the values of y. So if this is close to 1 or -1, that means this is a nice fit for the information that I have. If this, the r value, is close to 0, means there's no correlation, means there's no association between the variables. So the closer to 1, the better. The closer to -1, the better. If the r is positive, why? Because my correlation is a positive correlation. If the r is negative, then the correlation is negative, goes down. Okay? That's it. Now let's go and continue the problem. Okay, we're here. Oh, I gotta erase all this. Eraser. So these are the table values that I have. This is the information. Let's read all these questions. Draw the scatter plot. I have it already. Find the equation of the line containing the first and the last data point. My first and the last. What's going on here? They want me to write the equation in slope-intercept form. using these 2 points only. So this is a regular equation. For that, I gotta find the slope and the y-intercept. My slope, y2 minus y1. I have my 2 points. This is, let's write it here. 4, 2, and the second point is 10, 14. x1, y1, x2, y2. Alright, replace it here. y2, 14 minus 2. x2 minus x1, 10 minus 4. 12 over 6, 2. So my slope is 2. My slope is equal to 2. I gotta find the y-intercept now. An easy way how to find the y-intercept, guys, is writing the equation in point slope form. This is just an idea. You can find also the y-intercept in a regular way, but this is a different way. Let me show you. So y minus, technically I can find the whole equation just doing this. Once I have my slope, let me replace my slope and 1 point. This is called the point slope form. So y minus y1 equals m, x minus x1. Y minus y1, y1 is 2, equals slope, which is 2, x minus x1, which is 4. So I replace the y1 and the x1, and then I distribute 2 times x, 2 times -4, leave the y by itself, plus 2, and I have y equals 2x minus 6. So this is the slope-intercept form when I use 2 points from the data. Okay, that's question B. Graph the line found part B. You plot those points. Use a graphing utility. So that's the idea about this lesson. Graphing using Desmos in this case, or a graphing calculator, and to find the line of best fit. Line of best fit. The green line. That's the line of best fit. What is the correlation coefficient? 0.9965. R is 0.9965. Use the graphing utility to draw the scatter plot and graph the line of best fit. That's what we have in Desmos. Alright, so technically we're done with this problem. Let's do another one. Let's get into I found this one and I think it's funny. So let's do this one, guys. So a professor wanted to find a linear model that relates the number of hours a student plays video games each week, age, that's going to be my age, to the GPA, and that's G. He obtained a random sample of 10 full-time students and asked each student to disclose the number of hours spent playing video games and the student's GPA. So again, this is just 10 people. True, false, I have no idea. It's just funny. So we can play video games, guys, but don't go crazy at it. Imagine 13, 14, 15, 20 hours. That's too much. So we're gonna answer a few questions about this thing. Let's organize this. So my first question is, explain why the number of hours spent playing video games is a dependent variable and the GPA is a dependent variable. Okay, so why the number of hours per game is the independent and this one is dependent? What's the reason? Because remember, the idea of this is to interpret or predict, basically. Yeah, the number of hours is used, right, to predict how much it will be the GPA. Right, the idea right now is to see if this affects the GPA or not. That's the whole idea. So how do we start? We start thinking, or how many hours am I playing? And depending on this, the GPA is affected. So that's why this is dependent on the number of hours. All right, that's the reason. This is the independent and the GPA is the dependent variable. All right, the next question is to draw the scatter plot and find the line of best fit. So let's get into Desmos and let's put all this information in Desmos. Once we're here, we gotta go fill all this table. So let me fill it. Now that we have all the information in our table, let's right now we know what to do. Y1 Let's get into the approximate right now. ABC approximate equal to mx1 plus b. Okay, and I have my information right now. Let me break this down. Now, if you notice, where are my points? Where are my points? They went away somehow. Let's get them. So what's the easiest way to find them? I'll check. My x was from 1 to 13, so I'll come over here to, I forgot about the name of this thing. So I'm going to go from, if the lowest value is 1, let's put 0. And 13, so let's put 14. 14, let's erase the both values. And the lowest value here is 389, 282, 2.5. So let's put to like 2.3 or something. So 2.3, and the highest value is almost 4. So let's put 4 as the y. So what I'm doing is I'm changing the ranges. Okay, I hope you noticed that. The x between 0 and 14, the y between 2.3 and 4. And I found my points. There we go. You see that? So it helped me out. Now once I have this, I can just zoom out a little bit and I can see all the points in the line of best fit. So as you can notice, the points are kind of a little bit scattered, but I can see the trend. The trend is going down, all right? And the line, so this is a negative correlation. And the line of best fit is telling me, you know, this is an approximation of all those values, all right? Let's see what the R is. The R is negative 0.6, so it's not really a great correlation, but again, you have to go through the middle of the values, all right? So if this gets closer to to negative 1, means it's a strong relationship between the variables. But in this case, not too strong because the values are a little bit scattered, you see, a little bit far away from the line. All right, so let's write our equation. So my equation is y equals, where's my thing? Here we go. So my equation, approximate equal, right? You don't want to write equal, you want to write y. Approximate equal to is a negative slope, which is 0.6223, x plus 3.5124, and that's the line of best fit. This is my scatter plot. Graphically, this is the line of best fit. This is the equation of the line of best fit. The R, I will ask you for the R, negative 0.6223. All right, what else can I ask me for this? That's about it. I just realized that I I didn't use my slope. I used the correlation coefficient. That's a mistake. I apologize, guys. It's been a long day, I guess. So my slope, here we go. Negative 0.0. I'm so sorry. 617. All right, here we go. That's a better one. That's the slope. X plus b. I hope I wrote my b correctly, right? 3 is 5124. Got it. 5124. There's so many things. You know, when you graph, when you plot these things, so you got to be careful with that, and don't make my mistakes. I apologize for that. All right, cool. Again, correlation coefficient is negative as well, and I think that's why I got confused. I saw them too. Yeah. All right. So this is wrong. Here we go. So let's get back to the PowerPoint. So let's answer questions. Explain with the number of hours. I explained that already. We found the line of best fit. We plot the scatter plot. We draw the line of best fit. So that's pretty much it. Oh, hold on. They can ask you to predict for the future. Something like this. So this is some of the questions they can ask you. Interpret the slope. Interpret the slope. This is a negative slope. Okay? Remember, and I put y, I shouldn't put y and x. My variables are original problem, H and G, H and G. So this should be H and G. So H, instead of the X, I should have 0617 H. Okay, and here should be the G, because the G is the GPA, and that's the dependent variable. Here we go. Okay, or I can also say f of H if I'm doing function notation. 0617 H, but again, everything depends on the number of hours I play. So the question is, interpret the slope. The slope. If the number of hours playing video games in a week increases by 1 hour, the GPA decreases by, this is your slope, decreases. Why? Because it's negative. It decreases. It increases if it's positive. All right? The slope is the rate of change. So you have to keep that in mind. The GPA will decrease by the slope. All right. Next question. Predict the GPA of a student who plays video games for 7 hours each week. 7 hours each week. Find the GPA. What do I do? This is your GPA. This is the number of hours. So predict the GPA. This is the question. How much is Y when the student plays for 7 hours? Instead of the H, you replace it by 7. 0617 H, 7 hours, plus 3.5124. And then you do the math, and your GPA should be, my answer is 3.0805. But because the question is the GPA, so normally GPA is you round it to 100, 3.08. Okay. The last question: how many hours of video games, video game playing does a student play whose GPA is 2.4? The other way. Now they're giving you the GPA, and they're asking you for how many hours. So what you do is the other way. If this is your function, what you're going to do, you're going to plug the G here. So it's going to be 2.4 approximate, right, equal to negative 0.617 of H plus 3.5124. And from there, you solve for H, because the question is how many hours the student has to play in order for the GPA to drop down to 2.4. From here, you solve for H, minus 3.5124 on both sides, 3.5124, 3.5124, 2.4 minus that is equal to negative 1.1124, approximate equal to negative 0.0617 of H. Last step is divided by this value, negative 0.0617 on both sides. I apologize that I'm writing on top of the line, on top of the 617. So I have 1.1 negative that divided by this, divided by negative 0.617, and I get that the age is approximate equal to 18.03 hours. Let's round it to 18 hours. Okay. What else? This is a very difficult problem, just in case you don't know. A lot of ways that you have to think. Everything started with the scatter plot and the line of best fit. Okay. All right, guys. I hope this helped. Please subscribe to the channel. You have the subscription button right there on your screen. These are recommended videos on the sides. I'll see you in the next one. Take care. Make sure you subscribe to the channel. Bye-bye.